Ever wondered about the moon's hidden mysteries? Well, renowned physicist Michio Kaku recently unveiled shocking revelations from India's ISRO lunar mission, Chandrayaan-3. This mission unearthed lunar water ice, a potential resource for future lunar endeavors including drinking water, breathable oxygen, and fuel. But that's not the end of the story. Chandrayaan-3 has also made several other remarkable discoveries on the lunar surface that have sent shockwaves throughout the scientific community and space enthusiasts worldwide. In this video, we'll reveal what Chandrayaan-3 has discovered so far, its significance, and much more. Stay with us, and let's get started. Before we dive into the incredible discoveries made by the Vikram lander on the moon's surface, it's important to watch a truly breathtaking video. This video captures the Pragyan rover making its descent onto the lunar surface, filmed by Vikram's special camera positioned on its upper side. This camera serves the purpose of helping Vikram lander keep an eye on its surroundings and communicate with the Pragyan rover. In the video, you'll see the Pragyan rover gracefully rolling down a ramp that extends from Vikram's underbelly. It's a slow and cautious descent as the Pragyan rover carefully approaches the moon's surface, while Vikram lander looms in the background, keeping a vigilant watch. As you watch, you might also hear the sounds of beeps and voices emanating from the Mission Control Center, providing critical updates on the descent's status. It's important to note that the team back on Earth doesn't have immediate control over the lander or the rover. The vast distance between our planet and the moon means that it takes roughly 1.3 seconds for a command to travel from Earth to the moon and another 1.3 seconds for a response to reach us. Due to this communication delay, the lander and the rover are pre-programmed to execute this complex operation autonomously, relying on their built-in computers and sensors. They must rely on their own intelligence and capabilities to ensure a safe and successful landing on the moon. This video stands as a testament to the remarkable synergy between the Vikram lander and the Pragyan rover, working together seamlessly to accomplish this historic feat. Following the successful lunar landing, the Pragyan rover captured an astonishing image of the Vikram lander standing tall on the moon's surface. This image was taken using the Pragyan navigation camera, positioned on its front side. And that's not all. There's another video that showcases how the Pragyan rover skillfully navigates the lunar terrain and avoids potential hazards on the moon's surface. We'll delve into the details of this in the upcoming section. But for now, let's concentrate on this remarkable footage of the Pragyan rover making its descent to the lunar surface. In this image, you can see the Vikram lander standing upright, firmly supported by its four legs, positioned on a flat area near a small crater. Notice the main engine at the bottom, which played a crucial role in slowing down the descent and ensuring a gentle landing on the moon. This image serves as undeniable evidence of India's triumphant moon landing, an achievement not easily attained. In fact, only 3 other nations, Russia, the USA, and China, have achieved this remarkable feat before. Landing on the moon demands pinpoint precision in timing, navigation, and control of speed and altitude. The consequences of any error or malfunction during this phase can lead to mission failure or even a disastrous crash. It's no wonder that landing on the moon is often referred to as the most challenging aspect of any lunar mission. This image isn't just about marking a successful lunar landing, it's also a heartfelt tribute to a true legend in the world of space exploration, Vikram Sarabhai. He's often called the father of India's space program, and for a good reason. Back in 1969, this visionary scientist laid the foundation by founding the Indian Space Agency. He didn't stop there. He kick-started numerous space projects across India. But his pioneering spirit extended well beyond space. He made significant strides in fields like nuclear physics, cosmic rays, meteorology, education, industry, and social development. Now let's shift our focus to another fascinating video, this time featuring the Pragyan rover's maneuvers on the moon's surface. This remarkable footage was shot by the Pragyan rover itself using its trusty navigation camera. The video showcases the Pragyan rover in action as it skillfully navigates the lunar landscape, all while being powered by the energy of the sun through its 6 wheels. The Pragyan rover is not just an ordinary vehicle, it's the star of the Chandrayaan-3 mission. Its primary mission is to explore the lunar South Pole region and conduct a wide array of experiments and measurements. Lastly, we have temperature. The moon's temperatures swing wildly, depending on whether it's day or night or if it's basking in sunlight or shade. Temperatures can plummet to minus 156 degrees Celsius during the frigid lunar night and skyrocket to 121 degrees Celsius during the scorching day. Such extreme temperature shifts can wreak havoc on the rover's instruments and components, potentially causing damage. To tackle this hurdle, the rover features a top-notch thermal control system. This system uses insulation, radiators, and heaters to maintain the rover's temperature within safe limits, ensuring it can function effectively regardless of the lunar weather. As you've seen, the Pragyan rover is no ordinary machine. It's got brains and brawn, and it's built tough to withstand the moon's rough conditions. But it's not just a robot. It's curious and adventurous, always eager to explore new, uncharted corners of the moon. This little machine is on a mission to uncover the moon's secrets, and it's doing a remarkable job at it. Now, let's shift our focus to something rather fascinating. A graph that tells us about the chemicals found in a piece of lunar soil. This data comes from Pragyan's laser-induced breakdown spectroscopy, or LIBS, instrument. It might sound fancy, but it's one of the main tools the rover uses to figure out what's in the lunar dirt. Here's how it works. LIBS uses powerful laser beams to zap tiny bits of lunar soil. When the laser hits, it creates super hot and tiny bursts of light called plasma. The instrument then catches this light and looks at its colors to figure out what elements are in the soil. This mission has a specific goal to study the soil in the South Pole region of the Moon. This is a distinctive area with characteristics that vary from other parts of the Moon. This region is of immense interest for various reasons, as pointed out by Michio Kaku. He emphasized its significance, describing it as a historically and scientifically intriguing spot. Many nations are vying to explore this region as it has the potential to serve as a base for future explorations. Furthermore, the discovery of water at the Moon's south pole holds paramount importance for future missions. This water could potentially serve as a valuable resource, providing fuel for rockets and spacecraft, as explained by Michio Kaku. Analyzing the lunar soil composition yields valuable insights into the Moon's origin, evolution, geological processes, and activities. Interestingly, the analysis results presented an unexpected revelation: a substantial presence of sulfur in the lunar soil of the South Pole region. Sulfur is a vital element for life, forming a part of various biological molecules like amino acids and proteins. Additionally, it is a key component in volcanic activity, frequently found in magma and lava. Sulfur's presence also hints at potential meteorite impacts, as specific types of meteorites contain this element. This discovery is not just exciting, it's genuinely intriguing, as it has the potential to reshape our understanding of the Moon and its history. Now, sulfur isn't the sole element uncovered in this crucial lunar region. The Pragyan rover also detected several other elements on the Moon's surface, including magnesium, aluminum, silicon, calcium, titanium, iron, and sodium. According to Michio Kaku, these elements hold essential keys to understanding the Moon's geological history and how it has evolved over time. As for the Vikram lander, it has played a significant role in this Chandrayaan-3 mission, and it's worth noting that it also recorded movement on the Moon. However, it has been placed in sleep mode after successfully accomplishing its scientific goals. You might be wondering why it was put to sleep. Well, this decision is closely linked to understanding the temperature of the Moon's surface, a parameter that was carefully measured using Vikram lander's CHASTE instrument. CHASTE, which stands for Chandra's Surface Thermophysical Experiment, is a scientific gadget placed on the Vikram lander. It serves the purpose of measuring the temperature characteristics of the lunar topsoil around the pole. By checking the temperature at various depths below the surface, CHASTE can craft a thermal map of the Moon's hidden layers. This is a major aim of the mission, especially in the distinctive South Pole region, which differs from other parts of the Moon. The findings from CHASTE's measurements tell us that temperatures in the South Pole region fluctuate dramatically, ranging from a bone-chilling minus 156 degrees Celsius at night to a scorching 121 degrees Celsius during the day. This solidifies the fact that the South Pole area is among the Moon's coldest and hottest zones, presenting significant challenges for both survival and exploration. If it can, its mission will involve seeking out water ice and traces of hydrogen, valuable resources that could be used to produce water and rocket fuel. Meanwhile, India is also embarking on an exciting mission to study the Sun in unprecedented proximity. A bit over a week after India made history by landing on the Moon's south pole, they've taken another big step in their space exploration journey. This time, they've sent a rocket to study the Sun, which adds yet another impressive achievement to their growing space program. The spacecraft, known as Aditya L1, lifted off from the Sriharikota Space Center in southern India. Its mission? To get a closer look at the Sun from a spot about